So as the name of the chapter goes, it's called as mathematical physics, right? Why do we call it as mathematical physics? Is because these are the mathematical concepts we are going to use in most of the physics concepts. That's it, as simple as that, right? So this is the name of the chapter, right? See, I'm sure you would have learned the concepts of differentiation and integration, right? Is that what they started with? Right. First, differentiation means this thing. These are the formulae. This is what you need to do, right? But that's not how you learn it. Okay. So before you learn the concept of differentiation, see, going forward, whatever you learn, right, I'll give you the reason behind why you're learning and how you're supposed to learn. Okay. So if you see, the first concept that we need to learn before differentiation is called as slope of a line. Okay, it's called as slope, right? So let's take this remote for instance. Okay, and let me take my hand as a flat surface. So if I keep the remote on top of this, right, how is it appealing with respect to your eyes? Is it not horizontal? Is it not exactly horizontal? So if I take the same remote, instead of inclining both, if I keep my hand like this and I incline this remote with respect to my hand, can you say that this remote is making some angle with respect to my hand? You're able to see an angle here, right? So meaning of it is, if I take this key, for instance, I keep on top of it, I keep on the top of the horizontal surface, it is going to rest. Whereas if I try to bend it like this, what is happening? It is sliding, right? Because what was happening in the first scenario? It was flat. Whereas in the second scenario, it is inclined, right? The best example for this is when you go for the shopping malls or something, right? You would have seen the parking lots are always kept at the bottom. So you either go down the slope or you come up the slope, right? So to visualize it, basically slope means if there is an inclination of a surface with respect to a horizontal. Can I say that? Are you able to visualize what I'm saying? Yeah. So if I take this to be the horizontal surface, and if there is an inclination of the surface with respect to the horizontal, let me call this as theta, then I can say that this line is at a particular slope. Or I can call this inclination itself as a slope. Right? Can I say? Right. Now, basically what happens here is, if there is one line like this, if there is another line like this, right? If one of the lines is fixed and the other line is rotated with respect to it, then we get a parameter called as an angle. So basically, how do you define angle? If someone says angle is 60 degrees, what is the meaning of it? Incline means what? So the angle is defined between whom? Angle is basically defined between two lines. So what you actually do is, if I keep this finger as one of the lines and this marker as the other line, right? If I rotate it like this, can I say this stylus is making an angle with respect to the horizontal? Means, can I say it is rotated with respect to a fixed line? Right. And one more important thing that needs to be addressed here is, in which direction is this line getting rotated? So with respect to you, which direction is this? It is rotating in this way. This is called as anti-clockwise, or you call it as counterclockwise, right? What about this direction then? It is going to be clockwise, right? This is simple. Now, going forward, whenever I speak about angles, right, I'll ask you whether the angle is positive or negative. So in mathematics, an angle is said to be positive if the measurement is made in the anti-clockwise direction. Am I clear with this? Similarly, an angle is said to be negative when the rotation is made in the clockwise direction. Am I clear with this? So what I'm doing is, I am marking something like this. I'm not just putting that arc, rather I'm putting an arrow mark. So here it is positive angle. Am I clear with this? Right. Now listen to this. Now, how do you define this slope of a line? So this line is making an angle with the horizontal, right? So slope of a line is defined like this. Tangent of the positive angle made by a line with horizontal. So what is it? Tangent of the positive angle made by the line with the horizontal. Are you able to understand what I'm saying? Now, when this is going to be the scenario, right? Listen to this carefully. What is this tangent I'm trying to speak about? It is tan. Tan of theta is what is called as slope of this line. The slope of line is always represented with the symbol small m. Okay. Tan theta is going to be equal to small m, right? So this is what we call it as slope of a line, right? This is a basic definition. Are you able to visualize what is slope? Right? Are you able to see? Right. See, had the line been horizontal with respect to this, then what would be the value of theta? 0. So slope would have been tan 0, means it is 0. So what is the slope of the horizontal? Slope of the horizontal is 0. Had this line been exactly perpendicular to the horizontal, then what would be the tan 90 is what? Undefined. So slope of y-axis, slope of something which is vertical is not defined. Because it comes out to be tan 90, no? No, slope is not an angle. Slope is tangent of the angle. Slope is a number. Right? So that's why this word is very important. It is the tangent of the positive angle. Why here, don't get confused. What do I mean by positive angle? Positive angle means the angle which is measured in the counterclockwise direction. Am I clear with this? So this is an important point to be noted. Right? So having said this, I am going to extend this concept to a coordinate geometry. That is, if I take the basic coordinate system like this, x-axis, y-axis, x dash and y dash. Okay. Then what I'm going to do is, I'm going to draw a line like this. And on this line, I will take 2 points. Let me call it as x1, comma y1. And let me call the other point as x2, comma y2. Okay. Now my job is to define the slope of this line. So for that, what I need to do is I will extend it like this. Then I will see what is the angle it is making with respect to the horizontal. So I'm very clear. I didn't say positive x-axis. I told only horizontal. When I say horizontal, the axis can either be positive or negative. Right? Don't get confused that positive. So you told positive, then why didn't you take it in the first quadrant? No. Okay. So having said this, from here, if I drop a perpendicular, and from here, if I drop a perpendicular, right? Then what is this distance going to be? This is x1. Am I right? So what about this distance? Obviously, x2. So what about this distance? So if I drop a perpendicular from here, then what is this distance? It is y1. Then what is this distance? y2. So y2 is basically the distance from the x-axis, and y1 is also the distance from the x-axis. So here I have tan theta. So logic is very simple. Trigonometry clearly says it is applicable only for right angle triangles, right? So what I need to do is, in this part which is looking like a trapezium, I'm going to construct a right angle triangle. So when I construct a right angle triangle, it will be something like this. Means from this point I have dropped a perpendicular. So let me call this point as A, let me call this point as B, and let me call this point as P. So if this distance is x2, this is x1, then how much is this distance going to be? If this distance is y2, this is y1, then how much is y2 minus y1? So if I take the triangle B, P and A. So if I take the triangle BPA, what is BP? Y2 minus y1. What is AP? X2 minus x1. Then what is this angle? It is theta. Because if this is theta, this is also theta. Why? They are corresponding angles. Am I clear with this? Now tell me, what is tan theta from this? What is tan theta? Opposite divided by adjacent. So it is BP divided by AP. Then it is going to give me y2 minus y1 divided by x2 minus x1. This is tan theta. If you observe this, can I write y2 minus y1 as difference in the y coordinates? So in physics, difference is represented by the symbol delta. So this triangle is called as delta. So delta y divided by delta x. So basically, if you know 2 points on a line and somebody asks you to write the slope of the line, what will you write it as? It is the difference in the y coordinates divided by the corresponding difference in the x coordinate. What do I mean by corresponding? If I write y2 minus y1, I should write only x2 minus x1 the denominator. I should not change the order of the subscript. Meaning, I cannot write y2 minus y1 here and x1 minus x2 here. That is wrong. So that is why it is defined as the ratio of the difference in the y coordinates to the difference to the corresponding difference in the x coordinate. Right? So tan theta will be equal to delta y by delta x, and this is going to be the slope of line joining 2 points. Right? Make a note of this. I'll tell you where you will apply this. Make a note of this. It will connect it. But good that you observed it. I wanted to ask that question. You would have learned differentiation as dy by dx. No? I'll tell you what is. That is the reason why I started with this. You will understand it. Why is differentiation important? And for you to understand differentiation, why slope is important? I'll connect the dots. Okay, till here it is clear. No? Right? It's very simple. Basically, if someone gives you a line, see how much is what is the angle made by that line with the horizontal, in which direction? In the positive direction. Always measure the anti-clockwise angle. Take tan of that anti-clockwise angle, that is slope. That's it. Okay. So this is something like an extended formula that we are deriving, provided you know 2 points instead of you sitting and measuring. Means if 2 points are known to you, right, you need not use a protractor. You directly can use this formula y2 minus y1 by x2 minus x1. Basically, when you use a protractor, it becomes a Euclidean geometry. Here it becomes coordinate geometry. That's the only difference. It's this point. It's point B. Let me do an example problem based on this. See, example. Suppose I give you 2 points, A 2, 5, B 7, minus 2. Okay, some random points. Right? There is a line passing through these 2 points, and I ask you what is the slope of this. So M will be equal to, what will you write? So y2 minus y1 divided by x2 minus x1. So this is y2. Minus 2 minus 5 divided by 7 minus 2. Am I clear with this? So what is the answer going to come out to be? It is minus 7 divided by 5. So slope of the line in this scenario is going to be minus 7 by 5. I told you, no, it's just a number. If you do y1 minus y2 by x1 minus x2 also, you get the same answer. Check and see. y1 minus y2, you can do it 5 plus 2. 5 minus of minus 2. 5 plus 2, 7 divided by 2 minus 7, minus 5.